So now we get to a crucial step. Here at the top we said we know we are in a state where the loop invariant is true. We do a repartitioning step, that's an indexing step, and we know then that we get in a state where this is true because no computation happens between here, and this is just equivalent to the loop invariant being true. At the bottom of the loop we can argue it slightly differently. We say we want to now derive the loop body in such a way that the loop invariant is once again true. So the question we should ask ourselves is, in terms of these different exposed pieces of the vectors, what state should we be in so that we actually are in a state where the loop invariant is true when we redefine what x top and x bottom and y top and y bottom are by moving that element from the bottom to the top. Okay, so this part right here I have now recreated right here. And what do we know? Well, notice that we redefine what x top and x bottom are. Okay. Now this is sort of like saying, look, x top becomes this, x bottom becomes this, y top becomes this, y bottom becomes this. So if we now think about what is it that the weakest precondition is leaving us in a state where the loop invariant is true when we perform this operation right here, all of these simultaneous assignments of different parts. Well, if you think about it carefully, this is like a simultaneous assignment where we're assigning to disjoint parts of the vectors. And what that means is that we can simply do textual substitution of these different pieces into the postcondition for this particular operation, which of course is just our loop invariant. So what does that mean? Do a textual substitution replacing x top with what it becomes. Make a textual substitution of y top, inserting what it becomes. And what we then get is that the state we should be in here is alpha is equal to the dot product of that plus the original contents. Now doing a textual substitution, we find that this is x0 chi 1, and this here is y0 psi 1. Okay? But the rules of linear algebra tell us that this here actually means that alpha is equal to this times that plus this times that. The dot product of this with that plus the dot product with this with that. And that's the dot product of x0 with y0 plus the product of chi 1 and psi 1 added to alpha hat. So this tells us what state we must be in right here. And this is where there's a slight discrepancy between your worksheet and my worksheet up here, because I've always preferred placing that state right here. Now notice that again, this is just an indexing step. So whatever is true just before that indexing step about the contents of alpha is also true right after, and therefore I've always preferred to put it here. In your worksheet, it occurs exactly where the weakest precondition of this step would happen. Okay, so we go over here and we say the state that alpha must be in right here is that it must equal to x0 dot product with y0 plus chi 1 times psi 1 plus alpha hat.